Okay, now let's look at question 6. A cafe sells mugs of two different sizes. We have a small mug which costs $2.75 and a large mug which costs $5.50. Altogether, they sold 12 mugs for $55. And how many of each mug was sold? Okay, for this, there are two ways of going about it. Okay, so I'm just going to divide this, and I'm going to call this solution 1 and solution 2 because they are actually both pretty similar. Okay, so we are either going to assume ASSUME that all mugs sold are large, or assume that all mugs sold are small. Okay, this is a trick. At first, either assume is all big mugs or all small mugs being sold. So if all mugs sold are large, okay, we have 12 times 550 for one mug, which will give us $66. Just hear me out here. And the difference, $66 minus the $55, is $11. That means we have an extra $11. And the difference in price between one large mug and one small mug is $2.75. So if we take $11 divided by $2.75, we get 4, which is small. So we have 4 small mugs, which means we also have 8 large mugs. Alternatively, if we assume that all mugs sold are small, that means we have 12 times $2.75 will give us $33. Okay, and now I'm going to take $55 minus $33 is $22. And we know that the difference between a large mug and a small mug is $2.75. So I'm going to take 22 divided by $2.75. I will get 8 large mugs. Okay, so either way, we have 8 large mugs. Okay. Question 7. CED. So we have C, E, and D. This triangle here, okay, is an isosceles triangle with a right angle, and ABCD and EFCG are squares. The length of BF is half the length. Okay, so I'm just going to erase this so that it doesn't, just to make things clearer. So we need to find the area of the unshaded part. And the trick here is to realize that I'm going to, what fraction of the big square is shaded? You see? So the unshaded part is 5/8 of the entire big square, which is A, B, C, D. So this is 6, and this is also 6. So we could find the area of DEC. Okay, so area of triangle DEC is half times 6 times 6, which is 18 square centimeters, which means that 1 is 9999999. So actually, I don't even really need this line here. So what is the area of the unshaded part? It's just 9 times 5, 45 square centimeters. And, well, what do you know? That's how it's done. For question 9, we have a solid and the shaded squares below. So which view is it? So this is actually the top view. Okay, so it is the top view. B, the solid is made up of unit cubes. Without breaking up the solid, what is the least number of cubes to be added to make it a large cube? So the property of a cube is that all sides are the same length. Okay, and if we look at the cube, the longest side here is 1, 2, 3, 4, which is 4. So we're looking at the cube, which is 4 times 4 times 4 is 64 cubes. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 8 cubes. So how many more cubes do we need? 64 minus 8, 56 cubes. So for B, 56 more cubes. Question 9 is an interesting question. Mark lost 25% of his cards to Irfan. So we have Mark and Irfan. 25%, we know it is also 1/4. So after Mark lost 1/4 of his cards, he had 108 cards left. So we have Mark. We can draw 4 units here. 1, 2, 3, and 4. After he lost 1/4 of his cards, he had 108 cards left. So we know 1 unit is 108 divided by 3, 36. So Mark lost 36 cards to Irfan. Okay, so this is 36 cards. That means Irfan got 36 cards. And after getting 36 cards, his number of cards increased by 30%. Okay, so we can also think of it as 30% means plus 310. So to think about it, we can think as Irfan originally having 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then he added 3 more units. So I'm going to use another color, which is green. 1, 2, 3. Okay, so this is excess. I'm going to draw them again. So like this. So this is 10 units. Whoops. At first. And this is the 36 cards that he won. So 12, 12, 12. At first, 10 times 12, 120 cards at first. Okay. Alternatively, we can also think of it as 3 units is 36, 1 unit is 12, so 10 units, 12 times 10, 120 cards at first.